As clean technology continues to proliferate across the globe, distribution grids will need to upgrade and accommodate their power demands. Saqib, welcome. What are the key elements of this upgrade?
So the most important thing is to ensure that you have the legacy equipment that has been running your grid. You have the supply chain safe. We saw what happened with transformers. That was a big pain for all the stakeholders. So we need to ensure that we have the basics covered. And the next part is digitalization and bringing the flexibility in that grid. Because previously our grids were very rigid, there was no bidirectional flow of electricity. So now you need to ensure that you have that flexibility and digitalization included in your grid. And lastly, you need to ensure that the carbon footprint of the equipment installed in the grid is also considered. So you need to consider the life cycle of the equipment. That means that the use of SF6 in the grid needs to be considered. We already see a lot of solutions out there, SF6-free solutions. One of the big issues is that utilities do not have a lot of confidence when it comes to digital solutions or SF6-free solution, for example, because they want to see credentials. They want to ensure that replacing the existing systems is not going to have an impact on the reliability of their grid, because reliability is the most important thing. So the upgrades would obviously include the basics, which is having enough cables, transformers, switchgear. So that's the basics. You need to ensure the supply chain of this. Then you add the layer of digitalization, flexibility on top of it.
When it comes to the market for this in Europe, the US, China, how do they compare?
Not all distribution grids are created equal. In US, you have a lot of overhead equipment installed. That means grid resilience is a big topic in the US. But that's not so much is the case for Europe. In US, a lot of investment is spent on, for example, vegetation management. Why? Because of events like, wildfires. That's a big threat to the distribution grid. Whereas in case of Europe, that's not, let's say, one of the top priorities. Digitalization is one of the top priorities. We already see some big DSOs moving in this direction. When it comes to China, over there dynamics are a little bit different. State-owned, state-run, state grid of China, really focusing a lot on the high-power grid. So transmission grid is really structured in China. It's already extremely digital. You have ultra-high power connections connecting different parts of the country. So it's really different requirements of different power grids, because that's how these were originally structured, depending on what was the geography like, depending on what type of generation that you had in the power grid. Some countries relied more on hydropower, some relied more on nuclear, for example, historically, and so on and so forth. So depending on all these factors, grids were developed in different ways, and that's why their priorities are different. So it's not very fair to compare directly apple to apple, but obviously everyone has a priority. US has higher priority on grid resilience. Europe has higher priority on digitalization, where China is really focusing on high power, long distance transmission.
When we talk about China, obviously the sales of EVs are skyrocketing at the moment. And I understand that part of your expertise is in e-mobility. What are the key market trends you've noticed? And do you think that the distribution grid is ready to accommodate the increased load that's coming from the e-mobility sector?
Increased load is one aspect, and yes, that it needs to be considered. We already have megawatt chargers. You put 5 of them together, you already have a 5 megawatt load popping up in the distribution grid. So obviously having that baseline power availability and MVA capacity available is obviously important. But extremely important aspect is that your EV charging infrastructure is able to communicate with the power grid, so that you're able to optimize how you're using EV chargers. For instance, if you have 10 EV chargers installed in one place, not all of them should be supplying equal power, for example, depending on the state of charge, depending on the availability of, depending on the tariff available. Right? So that's how you need to optimize, and that's where ability of the EV charging infrastructure to communicate with the grid is extremely important, so that you can perform load management, load optimization on the go.
Saqib, thank you so much for joining us and sharing your insights. For more insights into the energy transition, make sure to join the Enlit community.